Hi, I'm João Coelho. I'm a student at UFMG and I'm currently developing a project at the Compilers Lab using the Clang library. In this course, I'll show you how to use this library to build our own tools, more specifically Clang plugins. Today, I will introduce the Clang AST. I will assume you have already built LLVM in Clang, as this will be covered in other videos from this series, but feel free to write me if you're having trouble with the setup. As you probably already know, Clang is the C language frontend of the LLVM infrastructure. Its main goal is to generate LLVM IR code from C source code. So, what is the Clang AST? AST stands for Abstract Syntax Tree. It is a data structure used to represent the source code in a tree format. In general, it is much easier from the point of view of a compiler to understand and work with the program as a tree than as raw text. And the good news is that Clang, through its libraries, makes these structures available to us. So what does this AST look like? Let's take a look at an expression. Suppose we want to represent this expression as a tree. What is the first thing we must compute? This multiplication on the right. So let's start by building a tree for this part alone. We might build a tree for it like this. We have the operation we want to perform on top, in our case multiplication, and from the operation we have two branches representing the operators, 10 and 4. This whole thing evaluates to 40. Now let's bring in the sum on the left of the expression. Here it is. Again, the operation sum is on the top node, and the operators branch off of it. In this case, the operators are the 2 on the left, and the result of our multiplication on the right. And the answer, as expected, is 42. Let's now take a look at this very simple function, written in C. It simply returns the sum of two integers, and it's saved in a file called simple.c. We can use the command shown here to generate a textual representation of the AST for our function. This is the output. Notice, however, that there is some noise around what actually represents our sum function, namely some default type defs introduced by the compiler. Let's focus on the actual function. This is what actually represents our function in the AST. The root of our function is a node called function decl. This is how Clang represents a function declaration, and it holds information such as the name of the function, its return type, the types of its parameters, and even where it is in the actual text. Notice also that everything that makes up this function is kept as a child of the function decl node. Its parameters can be found as those parm var decl nodes at the top. And right below them, there is a compound statement. These represent groups of statements. In general, you can think of them as the statements that go within the curly braces in conditional statements, loops, and functions. In our case, it represents the body of our function, which only contains the return statement. Going a bit deeper, there is a binary operator node that represents the expression a plus b. If you'd like, you can have a closer look at the rest of the tree and try to get a feel for what it is in the code. It's important that we familiarize ourselves with this format because, as we'll see, when we write our plugins, we will be traversing the nodes of an AST and gathering information about them. Now that we've seen what the AST looks like, let's discuss how it is organized. First of all, Clang does not implement a single base class. What this means is, we cannot have a single method that is able to traverse any type of node in our tree. Instead, there are three core classes. They are decl, which represents declarations in our code. We've seen a couple of these already in our example. Function decl and parm var decl. There are, of course, many other kinds of declarations in C, such as variable declarations or struct declarations, and there are corresponding decl classes for each of them. Next, we come to statements. As you might have guessed, these represent statements in our code. We've already seen, for instance, the compound statement from the sum function. This one was quite obvious, as many are, because it has the suffix stmt. However, we've seen a less obvious example as well. The binary operator node. You might expect this node to inherit from an expression class, and it does. However, expressions inherit from statements, so the core class this node inherits from is actually statement. Finally, there are types. We didn't explicitly see any nodes in our example which represent a type object. However, type information did appear. We've seen, for instance, that the parameters of our function had the type int. Using the Clang libraries, we will be able to extract a type object from nodes such as these. These are some examples of type classes used to represent integers and pointers. Pretty straightforward. These are just a few examples of classes that belong to each core class, but as you might imagine, there are many more. I encourage you to write a couple of C programs yourself and have a look at the AST Clang builds for them. This will help you to familiarize with some of the vast library that composes Clang. Today we had our first look at the Clang as a library. The main reference used for this video was the official Clang documentation. When you're exploring the AST and find something new, that's where you can go to obtain more information about it. In the next video, I'll talk about the interfaces we can use to build our tools. Until then, you can email me with any questions, suggestions, or comments. Thank you.